Welcome everyone to the Generative AI Innovation Incubator. Today is the spotlight session for education and the future of work, which is our first hackathon. And I'm just going to give a few announcements. One of them is that you should check out the webpage that advertises more about the teams. You're going to be hearing from them soon. You can see that the URL here, and I will paste that into the chat. And I'd also like to encourage you all to tweet using the hashtag GAI3 about your impressions of what's happening here and any comments that you have, but of course, please be respectful. So today is the spotlight session. I am doing the welcoming. One of the main events is that we will have all of our teams for this hackathon presenting 3 minutes per team. And then we'll have 2 guest talks highlighting some work at CMU in the space of generative AI and education and the future of work. I also want to just mention that the final presentation will be on Sunday from 1 p.m. to 3 p.m. That's our public judging event, and we invite you to come and weigh in on that judging process. And then also on August 11th will be our closing ceremony for the summer events, where we'll have a closing team keynote by Jamie Teven, presentations by the winning teams, and some closing remarks, as well as next steps for the GAI3. And with that, we will move into presentations from our teams. And the first team that will be presenting is Social Sim.
All right. So we are Team Social Sim, and this weekend what we'll be focused on is building an immersive app that helps K-12 students on the autism spectrum develop social skills through firsthand experience in AI simulated scenes. Our team initially came together around this paper, Simulacra of Human Behavior, and the idea of using generative agents to simulate human behavior. And from that, we got really interested in the idea of helping people practice their social skills through scenarios with generative agents. And then after spending some more time there and connecting with a speech therapist, we learned about how children with autism really can use these types of applications and how much need there is there. So we decided to focus on building our solution for them. And we are going to be using a visual novel approach. We want to make it as engaging as possible and as fun as possible. So you can see a little example here of what our vision is for what the what this could look like. Going on to a little bit about our team, I think we're really excited about this project because you know, with generative AI changing everything, with a lot of fields, it's not a matter of if, it's a matter of when, and as this technology gets rolled out. And we just think that serving a population like this, it should be a priority focus, and that this is a technology that should come to them as soon as possible, and that we have a great multidisciplinary team to be able to do that. We have Xian, who's a learning scientist, myself, who has a background in public policy, May, who is in human-computer interaction, and then Clive and Isabella, who are both developers with a lot of experience in AI. So this weekend, you know, we're going to do our best to build out the initial pipeline, get everything working for a demo, and get a general version working. But some of the overarching challenges that we'll be working on from beyond this weekend will be things like tuning the model to really, for students to really behave in the manner that a speech therapist would deem most effective. So making sure the conversation level is correct. We have a mechanism called inner voice that kind of cues the students to help them along in the conversation, making sure that that's giving accurate cues. Additional features we might need to increase accessibility for students with varying needs. And the little things like optimization, such as processing time of API requests to really make that conversation feel alive. And so I wanted to share those challenges with everybody to kind of put out there some of the things that we could use help with. I don't think we're going to have a Q&A now, but any feedback or questions that anybody have would be greatly appreciated. You can drop it in the Zoom chat here or send me an email. Thanks.
Thank you so much. And next we will have poetry.
Can you see my screen? All right, so this is team poetry. We are looking to maximize creative expression because we believe that it leads to better learning outcomes. And so we are two people here, Dave and I, both of whom have spent a good last 10 years in the edtech space, primarily looking at edtech in developing countries, India in particular, and both expertise in language learning and math and science learning. So what's the problem that we are looking to solve, right? So in India, we know that less than 50% of students at grade 5 are able to write a proper sentence given a picture. And as this progresses, this is not only in middle school, but we also see such problems are seen in high school learners across the country, that students have problem in writing in English. And moving ahead, it's also seen outside of India in several parts. This is an article that is Carnegie Mellon University, which talks about, why students are underprepared about writing when they come into college, right? So we see this as a very relevant problem to be addressed. And what is a solution? A solution is an app called Poetry, which will act as your writing buddy. The app will introduce students to writing different forms of writing. Here is a sample of how our app would look like. You would start with writing a poem. There are different forms of poem that students could write. And clicking on any of these forms would give students an access to a semi-complete poem that is triggered through a prompt-based input to the GPT model. The students can also choose to write different forms of stories. It could be a third-person story, a first-person story. As the students submit their writing, here is a sample of a student writing, right? Students can get immediate feedback that is both personalized to them and also has specific aspects of writing feedback on their writing. So that's the entire idea, and why we think this will work, because we are combining the power of artificial intelligence, generative AI in specific, which allows us to harness the power of giving immediate feedback, because research shows that most students don't get feedback on their writing exercises, which acts as a lack of motivation from a student side in terms of putting in effort. And the feedback will also be processed in a way that it is in a language that is understandable for the child, right? But not only through generative AI, right? But we are combining this with the power of pedagogy, which is combining it with the common writing errors that students have made. So combining the two, we believe that we will be able to give access to increased learning opportunities for students in terms of writing. And that is how we think this idea will work. Thank you, and happy to answer questions and take feedback post this.
Thank you so much. And you can put questions into the chat. And our next team will be ELLM. LLM, we can't hear you.
Oh, all right. So I was saying that we are the team ELLM, and coming to the motivation for our project, during the pandemic, we realized that the power of online learning is immense. However, research shows that students with special learning needs could not reap the same benefits of this platform. It's challenging, particularly for them, because the current platforms are not programmed to engage and give back the visual, auditory, and kinesthetic experience. These students need immersive, multi-sensory learning experience that needs to be personalized to their individual needs. So introducing ELLM, which is short for Enabling Learning Longer for Mind. that will use the generative AI to create 4 E's to enhance the students' learning experience. Express is going to craft detailed messages from just a few incoherent prompts, helping learners express their ideas better, who otherwise would like spend a lot of time composing messages and losing the learning goal. Explain feature is going to explain the concepts in an easy to understand language and accommodate to diverse learning styles. Through exercise, we want to give them conceptual and practical exercises, and experience is going to enable visual, auditory, and kinesthetic experience. Our mission is to build technologies for the future, and generative AI brings us closer to achieving this mission of making e-learning platforms universally accessible. Thank you for listening to us.
Thank you so much. And the next team will be Dynamic Flashcards.
Hi, everyone. We're Dynamic Flashcards, an app designed to help people learn complicated information in an intuitive way. Oh, I guess I should probably share my screen. There we go. Okay. Yeah, we're Dynamic Flashcards. So this is a problem that's very close to my heart. As a medical student, I spend a lot of time going over really complicated information, trying to memorize intense topics, and I spend all day just looking at the same static flashcards over and over, leading to just rote memorization. And it's hard to track my progress, and they're not very enjoyable at all. So our solution is to create a dynamic flashcard app that adapts as I learn the material. Basically, we will take cards, and as I find the material more challenging, our LLM model will decompose those cards into more conceptual and easy to understand concepts, and then create a spaced repetition deck that will present that information according to how challenging that information is. On top of this, we're going to make this a fun and interactive app full of gamification and achievements that'll make my learning experience way more fun.
Yeah, so the way that we're accomplishing this is by breaking the task into sort of 2 primary components. The first is a browser plugin that allows people to create flashcards from the web content they view, either when they're looking at review materials or knowledge sources. The next component is a flashcard app that allows people to go through the deck that they're working on and use the flashcards like they would with any flashcard app. The main difference is that when our users say that a card is hard or they got it wrong, the app will automatically use a large language model to break down the card into the components needed to answer it. So it will break a complex card into multiple easy to understand concepts and then treat those concepts as their own flashcards, which go back into the deck. And then as the user becomes more familiar with those cards, they'll merge back into the main concept that the user was trying to learn. So far, we've got basically the 2 main pieces of our program developed. We've got a back end and a front end, and we're working on the models that are necessary to generate cards and decompose them. Yaron's going to take you through a brief demo of the app as it stands so far.
All right, so here's what we have so far. So here you see how a learner will first choose a topic on the front page and then see the first card of the topic that they are wanting to practice. You can see that there's placeholders, and then once a student has their answer ready, those placeholders will be filled out and accordingly will go to the next card. And there's also gamification on the next slide. So while students are practicing, they will be able to collect, for example, things like stickers. They will also have a daily streak depending on their gamification type. And so we will personalize these gamification elements according to the type. So to conclude, we can definitely win this challenge. We are a strong team with a diverse background. We have very concrete and achievable goals here with a person from the medical domain and 2 people, Jeremiah and me, who have been working on LLMs and gamification. So we're really excited for this project, and we really hope that you are too. since it has immediate benefits for a lot of medical students. And I think it's very easy to expand this idea to other domains, such as physics, mathematics, or languages. Thank you.
Perfect. Thank you so much. And our final team is Chat TA.
Hello, we're the Chat TA team, a group of students from 5 different institutions with diverse expertise in full stack development, NLP and AI education, and business modeling. Design and analysis of algorithms, a fascinating course for aspiring computer scientists, but the price, $4,000 to $7,000. And for many people, this is extremely difficult to afford. But then we see this course on edX, exact same course, except one difference. It's completely free. A large part of this price difference comes down to the lack of human teaching assistance and support in the free course, which leads to students missing out on valuable educational resources. Additionally, TAs have a limited amount of time and bandwidth to support students. A solution? AI TAs. However, traditional AI TAs, such as Jill Watson, rely on rule-based systems which restrict their ability to handle complex queries. Overcoming these obstacles, there's GPT-4, which possesses the ability to understand and generate human-like text. However, tools such as ChatGPT simply can't be trained on different knowledge bases. And solutions such as Khanmigo don't support the notion of continuous improvement of the answers based on human feedback. Enter ChatTA. Our solution recognizes the power of LLMs and training our model on specific knowledge bases, as well as seeking human input in bridging the gap between AI capabilities and human needs.
So how are we going to do it? This is the pipeline. That's a little bit technical, but these are 3 components. Information retrieval from a database that we build with all the instructional material for the course so that our answers are factually grounded. Second, we fine-tune our own model, our own llama-based model, so that we have control of the performance and the privacy of the data that we use. And then third, a reinforcement learning from human feedback components so that there's continuous improvement, as Ashika mentioned. What is reinforcement learning from human feedback? You might have heard of it. It is the technology that's groundbreaking, and it's aligning all these assistants that you see, like GPT-4, Claude, all these models, they're great assistants. So this is what we're going to use with our own model. Ultimately, sorry. I'm sorry. ChatTA in a nutshell, as students, we are in our universities, we are TAs and students in our universities, we need ChatTA. We understand how valuable the time of TAs and students are and how expensive higher education can be. We want to make it safe, private, and cost-effective. This is ChatTA in a nutshell.
Recording stopped.
Very good. Okay, so now we have heard from our 5 teams, and we have some very exciting work all lined up. And next we will have 2 guest talks that are about research going on at Carnegie Mellon in the space of large language models and education and the future of work. So our first presenting team will be David Kaufer and colleagues. Can you please share your screen?
Can you see this?
Yes.
Yeah. Okay.
Suguru is going to talk for our team. Yeah, thank you.
Okay, so we have David Kaufer and myself, Suguru Ishizaki, and Nick Ryan. We are all from the English department. We've been working on the tools for writing instruction for 20 years, and we've been recently working with natural language processing. And in the past year or so, we've been incorporating generative AI as well. So I'm going to show you a snapshot of what we're working on, and then see what happens. Okay, so I'm going to move a few things around. Okay, so we think there are mainly two currently problems in writing in colleges and universities. There are more problems, two things that we are currently addressing. And first is generative AI policies will not going to work, and banning it is not going to be productive either. So we're thinking that what would be the ways that we could really promote the responsible use of AI using tools that we're creating. The second thing is a age-long problem. Many students do not like writing assignments because it is one of the most challenging tasks that they have to work on. And while, especially they're working on, like, for example, they're on disciplines like computer science, mechanical engineering, or fine arts, whatever it is, they have to write something during their course of study, but writing is not what they get excited about. So why is that? So the many years of research in writing instruction, especially at CMU, we did a lot of cognitive studies of writers in 80s and later. So there's a student writer. There's a lot of things that this student writer needs to do. Have to have a good knowledge of what they're writing about. And they have to know who the audience, the purpose of the writing is. And they have to generate ideas, organize ideas, set goals like what to write first, what to write next, what kind of argument to use, and then translate all these ideas into a linear piece of writing. This is supposed to be a very, very cognitively costly operation that students has to go through. And then once some sections are written, they have to review and evaluate. Is organizations good? Content accurate? Is it having appropriate tone of voice? And then go back to generating ideas or retranslating the sentences and things like that. So it's a lot of work, and writers must juggle many of these cognitive demands simultaneously. This is really a very difficult task for many, especially like early writers, that they have to really learn academic writing or writing in the professional disciplines. So our solution that we've been working on is to use the generative AI to do the translation, except that we're not going to generate ideas, but let the student generate ideas, but we really turn ideas into prose. That's the way we're using the AI technology. And also for reviewing, to understand, for example, the organization of text, that's like 3 pages. You have to carefully read and understand if the organization is working well, or if the like a text is meeting the requirement or expectation of the audience. You have to carefully read it. So we have a visual inspection tool that allows you to get a sense of what's going on in the text quickly and easily. So combining these things together, we're kind of dropping some of the cognitive tasks that students are facing when they're writing, allowing them to focus more on the idea that they're trying to write. So I'm going to give you a brief overview, a quick demo of what we have and changing this. So this is our writing environment. Middle part is a text editor. Left side, we happen to have a expectations panel for a proposal and change proposal. And here's like an outline and expected information that you have to include in the text. What is the purpose of the document? What is the current condition you propose to change? Let's say we're writing a proposal to change the campus dining, which is not really good, for example. And what students usually do is to change, copy the outline into their own text environment. So they copy it here quickly, and then start writing notes, for example, here. So since I don't have time a lot here, we already have notes that I put here. For example, what is the current condition you propose to change? I just list of like a food services and what they are, buffet style, fast casual grab and go, or coffee shop, just listing. And then room for improvement. Students with food allergies have limited choices, no monitoring of new choices content, no monitoring of whether vendors rely on ethical supply chain. Those are things that this author want to address. So, but we're not really writing prose, we're just jotting down notes here. Here's the note, assume that I wrote this down here, and I would just say, okay, I want to turn this into prose. So choose generate prose from notes. And then you ask the generative AI engine to generate a prose, but use the idea written in the notes only. Don't add new ideas, don't add new concept. This is all what I'm writing about. Just create a coherent prose. So this is the prose that was being generated. And you can make it read it if you don't want to read it. And you can make some edit here too if you want to, but I'm not going to do that here. But let's say if you happen to like this, then I would say, I'm going to replace the text here. Okay, so you get this text. And then we'll do a couple more just to show there's a bullet list of what are specific problems you propose to address. And here I'm going for other specific proposed to address here. So most writers don't write linearly. So you could just jump around and like fill in things that you could write. That's what usually students would do. And let's say generate pros from notes. And then say you could review this and edit this. And if you like it, you just replace this. So you keep going like this to draft a text. Okay. So I'm going to just open the text that's been already written, the larger text that filled out the entire requirement. Let's see here. So here's the whole text. One thing you could do on the left side is, for example, here's a coherence. And here's a third paragraph of these topics, seventh paragraph of these topics. It just gives you a sense of what topics are being used. When you click here, you see a diagram of, okay, sentence 1 through 7 is using these topics to discuss about things. So food is discussed in every sentence except 7. Health is discussed in the first 3 and the last one, for example. So you could kind of get a sense of map what it's written. But then if you find that something that you should have written or you expect it to write, but it's not there, then you would notice that relatively quickly without reading the whole thing. And often when that happens, your notes under-specified your concept. So you didn't really put your notes because AI scribe is not adding any new ideas. And it's really you who didn't put the ideas into the notes. That's how you go back and forth to edit the text. The other thing you could do here is, another use of AI is that here is a set of expectations. Let's just pick the second one. What are the current conditions you propose to change? Then I say, find sentences that meets this expression. Am I addressing this particular issue in this text? So I'm just going to ask AI to say, okay, identify these specific sentences that satisfy this particular area requirement. It takes a few seconds because it's a relatively long text, but if you wait for a little bit, it will make a list of sentences. Let's see. If it takes too long, and I might just like skip to the next part of the presentation. Okay, so it's taking a little long. I'm going to just switch. Oh, it did. So it makes a list of sentences here and also highlight them here so that you can kind of see. Sometimes if your text is not meeting the requirement, you don't see any highlighted text too. Then you could start thinking about why did I not address these issues? So that's how you could kind of assess your text. Also, this could be used by TAs and instructors to kind of see if your student text is meeting the requirement that they set out to ask student to like satisfy as well. So just quickly summarize what we are interested in. So our hypothesis is that with this kind of tool will promote the responsible use of AI, because we heard that some students don't really want to use ChatGPT because it's cheating and also they can't learn anything. But this one will allow those students who really want to learn to write quickly, but still learn the concept they're interested in learning. And that means that we're allowing students to focus more on learning in non-writing classes where writing is a requirement, and they could focus more on ideas and what they're writing about. And we also think that this would level the playing field for all students. Some student might come with the background of like a good writing teachers, but some student may not. So depending on their background, possibly a student could be a multilingual student and may not be comfortable with writing. So tools like this could also level the playing field for all students. And finally, these kind of tools will help students to develop higher level writing skills because they don't have to worry about sentence craft and making sure that all the sentences are connected well. And this will give them an idea of like they could focus on argument, organization, messaging. Those are the kind of things that they could focus with this tool. So this is it for my quick presentation. I spoke so fast, but if you have any question, I think we could address that as well.
Yes, we can have a couple of questions. Would anybody like to ask a question? If you'd like to avoid having your voice and video on the recording, you can put your question into the chat. Or you can raise your hand and I'll call on you. Okay, somebody's asking, how can they access it to go ahead and use it?
We're trying to make that happen as soon as possible. That's our a top priority at this moment. It's living on one of our computers right now.
Okay, next question by Paul. Paul?
Hi. Hi.
Oh, that's Paula, sorry.
That's okay, Karen. I was wondering, very good presentation. I love the idea. How do you check that the generative sentences connect well between them at a level of a paragraph that address all the requirements that you mentioned, as like whether they are addressing the requirements?
Dave, do you want to answer that?
I'm not quite sure. Could you just state that again? How do you know whether the chat
whether the sentences are at a paragraph level address the requirements of the idea that it had to convey the student in that paragraph?
Right. So I think the question is, can the generative AI create like a cohesive set of sentences that makes sense? But interesting that if you write notes that are quite incoherent, then it may not be able to do a really good job, that you might notice that. Or generally speaking, if your notes are generally coherent, and generative AI, the ones that we've tested, seems to try to create a cohesive set of sentences to start with. Doesn't mean that it conveys the ideas well if your notes are kind of like a rough, but generally speaking, but then paragraph to paragraph, like a cohesiveness are not guaranteed that well. So you have to make sure that you do that well yourself.
Yeah, I mean, go ahead.
Sorry, go ahead.
I mean, what we found is that the better your notes and the more refined your ideas in your notes, the more ChatGPT will give you good results in terms of the prose you want. The less refined your notes, ChatGPT will give you less refined. Of course, we tell it, we dumb it down. We tell it, don't add content. We tell it, don't add syntax or vocabulary or registers that are more sophisticated than what the notes are giving you. So, we try to do it that way. But on the other side, on the evaluation side, we find that, ChatGPT is a good text extraction tool. It can actually locate information and localize on it pretty well. So given the fact that these expectations are, and it takes some skill pedagogically that you have to be able to decompose your writing assignment into these expectations. But ChatGPT is pretty good at locating sentences that actually are responsive to those expectations.
Okay. Thank you. I'm currently working in something similar, and one avenue that I would love to see, but I haven't been able to develop, is the use of knowledge graph to make sure that you have all your ideas connected in the way you were expected to have them. Yeah, and check like whether the knowledge graphs make sense.
That tool Suguru showed is some kind of a knowledge graph, because it's actually monitoring the organization of topics and the progression of topics. So you can actually see, the student can see what are the topics I'm using, highlighting, and we didn't show you this, but the topics, that topical graph is actually syntactically smart. So it actually knows whether, you're actually using topics in a favored position, like a subject position, which gives it more weight and more importance than if it's simply out of the subject position or simply in some other slot that's not very important in the sentence. So it's really trying to do that sort of knowledge graphing that you're talking about.
Okay, I see. Thank you.
Thank you so much for your question, Paula. And we have time for just one more question, RT.
Yeah, thank you. So this is a very interesting presentation and very relevant to the work that we're doing. Though we're looking at learners who are going to school K1 to 10 segment. So my question is, I heard you using the GPT model for this. And the question is that, are you powering your prompt engineering using any of the corpus of student responses that you may have from the past? And what are your thoughts about that?
So we are currently not using the corpus of previous text to do the prompt engineering, except that like David and I have been looking at the corpus of student texts for 20 years, so it's all in our head. So specification, the prompt engineering would require a lot of knowledge in rhetoric, composition, and some of the specialized knowledge to specify what we want to extract or not, what we want to respond to be. That's what is behind the scenes, but sort of like beginning writers or college writers, student writers do not need to know some of those languages to specify the backend messages that goes into the generative AI.
Okay, thank you so much. This was very interesting. There are a bunch more questions in the chat. So I will encourage your team to read those and respond to them in the chat. And now I will turn the screen over to James Fiacco, who will give our final invited talk for today's Spotlight session. And you'll need to unmute yourself, James.
That would help. One moment. All right, can everyone see my slides?
Yes.
Okay, so as Carolyn said, my name is James Fiacco, and I'm a PhD student here at Carnegie Mellon University. And I'll be giving my talk that is titled From Pre-Training to Overfitting, a Journey of an AI Writing Detector. So we all know that there's a lot of discussion about the problem of students using generative AI to write essays that they're not supposed to. And of course, we don't necessarily want that to happen. So in response, we are also using AI to try to detect when students are doing this as one line of defense towards keeping students at least doing the assignments as the teacher intended. However, there is a concern that models that do this and might seem to be doing the task very well might actually be relying on shortcuts that lead to unsavory behavior. For example, this might mean treating non-native speakers of English in an unfair way by disproportionately predicting that their writing is AI generated. You can also imagine that there are many non-standard dialects that are used by even native English speakers, and we don't want to create a technology that will be widely used that would discriminate them. And there's been a lot of fear about discrimination in the media. And so much of my research for my dissertation is focused on how we can use these AI technologies safely. And what that requires of us is to be able to see underneath the hood of these models to see what is happening. What are our models learning? Are they learning these dangerous proxies? And if they are, can we steer their learning, or in the very least, can we select the model that uses them less? My whole dissertation is focused on increasing the visibility into what neural nets are learning so we can do this. And ultimately, I'm going to tell you a story, and we'll try to convince you of several things that we are seeing in our research. One of which is the way that the neural models are trained and evaluated largely values the accuracy of the predictions only at the final outcome. However, we need to pay more attention, not only to getting the correct answer, but also getting the right answer in a way we know is safe. And furthermore, we know that in generative AI, there is wide usage of pre-trained models, such as GPT or BERT, and we call those foundation models because a lot of work in artificial intelligence uses them as a foundation of their learning. But with respect to the tasks that we are using them on, it is very likely that there are patterns that they have learned that might inadvertently provide building blocks that lead to the biased behavior we are worried about. And so we need to understand, what is it from those foundation models that is coming through into the downstream models that we are training on top of them? And how can we be looking out to make sure what we are taking from them is actually safe? We also need to know look what happens when we start with that foundation and shift what the model is doing towards a specific task, a process that we call fine-tuning. And so I'm going to show you in this talk how we start with the foundation model, we fine-tune on top of that, and then we look on how that network organizes itself. And we have a way, which we call neural pathways, that allows us to see into that model and be able to ask these questions. So first, I'm going to start with the pre-trained transformer. This will be our foundation model. And then we fine-tune it for a task. The task in this case is determining whether an essay was written by a human or by a computer. And ultimately, the task to distinguish between a human written document and an AI written document is with the idea that a teacher might actually use this application to determine if a student has cheated on their writing assignment. So the cost of failure is actually very high. Now, while fine-tuning is taking place, there is an iterative process of adjusting the network, that is adjusting what it is that the model is learning. And what that involves is that some patterns that are a kind of building block in the decision-making process, and then they assign those based on values on the role. And this iterative process happens in stages. And in every stage, the data is examined and the model is adjusted. And each repetition of examining and adjusting is called an epoch. An important part of the development of a model is the choice of how many epochs we want to do, because with each one, the model is learning more about the data, but eventually it might pay too close attention to the details of a specific data set to such an extent that it might be less good at handling data that it might actually encounter in the real world. And when it gets to that point, we call that overfitting. So we need to be able to decide when we should stop this process so that we don't overfit. And in practice, that's usually about 1 or 2 epochs. So to provide a foundation in understanding how neural networks organize themselves, we will walk through a simplified view of a neural net. I'm going to be using the term activation and neuron frequently. And generally, when we refer to neurons, we are referring to outputs of a layer of a network. And the activation is the value of that output given some data. And while distinct from the weights of a network, they are highly affected by them, being that they are a combination of both the weights and the current instance of data. And because of this link to the weights, as we adjust the weights during fine-tuning, the activations produced by the neural network change, creating structures within the network. New structures within the network, I should say. And our goal, therefore, is to find out what is the meaningful difference between the network at different epochs during fine-tuning. To explain how we do this, I'm going to take a step back to a simpler form of machine learning called logistic regression, where we have a set of features that might be useful for solving the task. In our case, features that represent properties of an essay, and we take a weighted sum of them to decide the class, which in our case is whether or not a document is written by a human or an AI. Now, neural nets have long been understood to be feature extractors. Despite all their apparent complexity, they are in effect a method to extract features out of data and then perform a logistic regression at the end to determine the class. There are naturally more complexities than that, hence the asterisk. But for our purposes, we can assume this to be the case. Our goal then becomes how do we determine which features are actually being extracted? And to do this, we group coordinated neurons together into what we call neural pathways, because if they're correlated, given an input, then they are likely performing a similar function within the network. And we can then align those groups of neurons to more human understandable features. It is important to note that sometimes these features, such as slang words, can disproportionately target protected classes of people who have specific dialects. Now, because the activations change over the process of fine-tuning, the collections of pathways, that is, the learned features, may also change. A model may gain new pathways, it may lose them, and it may just reprioritize them. But often, a pattern learned by a model will be used by subsequent generations because it contained a valuable feature for the model for the given task. And we can find correlations between pathways in different epochs to find how these useful features are propagated and if they originated with the pre-trained model or were learned by the fine-tuned model. So So in our experiments, we used 3 data sets, each of which contained AI-generated content from GPT-3 or later. One of the data sets was to fine-tune the model, and the 2 others were to provide some sort of out-of-domain evaluation data, in this case, student essays, which would allow us to test if a model treats native and non-native English speakers differently. The foundation model that we used is a widely available AI writing detector for GPT-2, and we fine-tuned it on our GPT-3 dataset for 7 epochs, more than enough to ensure that the model fully overfit by the end of the experiment. And so I'm going to bring back this cartoon view of the pathways changing over epochs as a prelude to the more complex version of this diagram that uses actual data from the model. This is to demonstrate how each column is a summary for what is happening at the network at a specific epoch, and the connections between them link together similar pathways. And furthermore, the performance data, from the performance data, we can see that the model appears to do very well and peak at about epoch 1, which would indicate that that is the version of the model that we would want to use. Now let's bring in the actual diagram. Like the cartoon, each column represents a summary of the neural network at a given epoch, with each circle representing one pathway. They are ordered so that the ones closer to the base are more important. The pathways are building blocks, like subrules that the model uses to make decisions. So what this image shows is how these representations are changing. At epoch 1, we see that there is a contraction of the number of pathways, meaning that each individual pathway now explains more about the model. This corresponds to the model losing pathways that existed in the pre-trained model, that is the first column, but are no longer required by the fine-tuned model. As the model begins to overfit on the dataset, it learns more pathways that are more specific to the dataset, and the model reaches a ceiling in the training set around epoch 3. When that happens, it begins alternating what it finds important between more and more of the specific features to the dataset. However, if we highlight pathways that show a considerable correlation between it and times when the model cannot distinguish between a non-native English speaker and an AI-generated content, we see that there are some dire issues with this model. Specifically from the pre-trained model, that only contained maybe a few problematic pathways. These were latched onto during fine-tuning, such that all the important pathways were correlated with this bias. The new pathways generated while the model began to overfit largely inherited this bias as well. And it wasn't until the model had become so overfit that its pathways are not meaningful outside the training data set that the bias no longer appears. And all of this is further supported by the model's performance on the TOEFL dataset, where all of the fine-tuned models perform unacceptably. Therefore, the overall story here is that pre-trained models contain some dangerous proxies. They are not most of what's contained in that representation, but the model can quickly pick up on them and say, this is what I can depend on to get a quick boost of performance. Obviously, this is not very good. We wouldn't want to use this model. So if we continue to train, we would hope that the model learns some more nuanced rules. However, because those proxies are so strong, there is no room for nuance, and the model ends up only reprioritize things that memorize the dataset, never being able to reach its peak performance again when it was using those unhealthy features. And while this is clearly a model that one should not be happy with, it does show you how we can see what is happening. We can see how we might have been fooled into thinking it was a good model, and how that could get good performance, while under the hood, it was actually learning these harmful proxies. And in fact, if we needed to pick a model, we might be better off just using the pre-trained model, despite its apparently worse performance. It at least is not solely relying on these dangerous proxies, making it perhaps worth the sacrifice in performance. And this shows how important it is to be able to look underneath the hood. But even more than that, in machine learning, there is a potential for these models to learn biased behavior, not because they're inherently malicious, but because these shortcuts are extremely easy to find and can quickly get us to the end, but only if we do not care enough about the means that it uses to get us there. So yes, there are dangerous proxies that can lurk beneath the surface of models, but I hope I have shown you that there is a way for us to begin to look under the surface and really know what is happening. so long as we are watchful and so long as we are willing to sacrifice maybe a little bit of performance, we can avoid these dangerous proxies in order to get models that are safer and potentially more effective at generalizing. And so, like, in conclusion, it is easy to be afraid of artificial intelligence because the models are complicated and difficult to understand. But it is also just as easy to brush off all concerns if the metric you're only looking for is performance. But in my work and at CMU, we are committed to developing the technologies that allow us to be responsible in how we're deploying these models to ensure that they have as positive an effect as possible. And thank you very much. I open to questions.
That was beautiful, James. Thank you so much. Would anybody like to ask a question? Either in the chat or raise your hand. Be shy.
Hey, James. Hey, Carolyn. I was actually speaking, but I was having a
Oh, were you muted? Okay. Let's hear it from you, Anshul.
Thanks for the presentation, James. I was just curious about how you're evaluating the results of your work.
Like in general?
For example, you mentioned bias as one of the areas. How are you evaluating the results of your work with respect to bias, for example?
In the sense of how, like, what metric that we have to indicate that there is bias?
Yes, sure.
Yes.
Whatever your thoughts are on the evaluation process, including the metric.
Yeah, so we look at the correlation between these pathways and the actual and certain bias metrics. And if they are very high correlation, then we consider it likely that there is bias present. We are also looking into kind of mapping these pathways onto causal models that might reveal a little bit more about that, but that is some more early work.
Okay, thank you.
Okay, someone in the chat has asked about how you identify the pathways.
So identifying the pathways is somewhat a little bit out of scope of this talk. But it has to do with performing a dimensionality reduction, in this case, an independent component analysis on the activations of the network. And what that allows you to do is get kind of these maximally independent groups of neurons based on their activation patterns through some sort of evaluation data set. And then because they're as independent as possible, you can align them with features that you ensure are as independent as possible as well. There are several papers, some of which are under review that I would be happy to point to you to make this a little bit clearer. But hopefully that answers the question, at least at a high level.
Great. So there's another question about how much of this end-to-end process can be fully automated.
So a lot of the mechanics can very easily be automated. It's actually not a very complicated process to get from a trained model to the correlations thereof. The complexity comes from deciding what features to use as lenses in order to try to align these pathways. Choosing and being able to know what biases might be present in the data, to know to look for those, and that kind of that requires some task knowledge and expertise that I would find more difficult to automate.
Okay, so somebody has asked in the chat, I think that this could be a more nuanced discussion. So it makes sense to avoid overtrained features that only work on the training set. But let's say you did have a feature, it was correlated with a harmful external variable, but it was useful in some generalizable way. Would it be a bad idea to continue to use that feature?
So if your best evidence, that is like the best correlation that you can find with that pathway is with some sort of bias feature, you have to somewhat assume that it might be, it might be a problematic feature to use. However, there is the opportunity to look for other features that that part of the network might represent. And then if you can find better correlations with it that explain it better, then it might actually be safe, and it might just be a spurious correlation with problematic feature. But it does, it's all very like, evidence-based. Is like the more evidence that you have that is a problematic feature, the more likely it is to be, and vice versa.
Okay, we are at the end of our session, so I will just close with a few announcements. So I have already talked about our upcoming sessions. I'd like to encourage people to go ahead and enter any comments they might have into our usual form. My screen has gotten into a strange mode. I'm very sorry about that. And finally, I'd just like to mention that our application is live for our certificate that's being launched in fall. We are just about at our priority deadline for applications. So if anybody's interested in a certificate in computational data science, I encourage you to follow this link. And thank you so much for coming today. And I apologize to any people who, for whom there was a little confusion about the link. The recording of the session will be available fairly soon from our website for anyone who wants to watch the beginning that they may have missed. And thank you so much for coming today. And I invite you to come back tomorrow at 1 p.m. Please come to the link that was mailed out. I'll make sure that that we're all coming to the same link for tomorrow's judging event, which begins at 1 p.m. EST. Thank you so much. Bye.